Hi, it's Ray from Pro Shaper Workshop in Charlton, Massachusetts. We've been super busy. We haven't really kept up the video schedule that we hoped for, and really couldn't work on the Cadillac part tonight. That's what I was hoping to do. We just didn't have the time. So I'm going to do a video on some of the basics of English wheels. We did an English wheel basic one before, but I think we're going to try to cover a little bit more material on this one. I think everybody will find it very interesting. So we got the YouTube English wheel that we built, I don't know, probably a year and a half ago now. And we've been using it at the class, and the wheels get dirty a little bit. So first thing that you want to do is to make sure your wheels are super clean. Because in the process of using them, everybody has a certain amount of oil on their hands. They put a lot of magic marks on the panel they're working on, and that all transfers over to the wheel. So the technique I use works really good. I've probably shown this a couple times before, but there'll be a lot of people who haven't seen it. I did make a change though. I used exclusively 600 paper. That's what I used to use before. And this is actually used 600 paper that I've cleaned another wheel with, and it still works really well. So I use a cordless drill, and this is a drum sander the drum that you buy, and you put the sleeves, the drum sanding sleeves on here, and I get these from McMaster Car. And this is the Harbor Freight Hercules, the top of the line little cordless drill. And then the air sander from Harbor Freight, but this is our little adapter that we make and sell on our website, proshaper.com. And then we also sell the foam pads now, the hook and loop foam pads. All right, now let's polish up the wheel. We're spinning it up. And now that was 600, now we're putting 1200 on. That's shined up nice. Could stand a little bit more, but that's good enough for this video. Sometimes a little bit of buildup or something comes off of the sandpaper, so you gotta check it here. All right, so we got the wheels all cleaned and polished. Super important because any dirt on those wheels will print right into your panel. So you want to always keep your panel, your English wheel rollers in really nice shape. So the other things you can look for, now all of my wheels that I design and build, I have the ability to turn this one bolt here, and you can turn the wheels. Well, why would you want to do that? Well, if it's welded here and you've got a piece that's this long, I think this is a 36-inch throat, I believe. That's your limit. You're going to hit 36 inches. You can't do anything longer. But if you were able to turn this or completely around and turn it at an angle, now if you've got a long piece that's 12 feet long or whatever, doesn't matter. You can still wheel it because you're not going to hit the backbone. So being able to turn the yokes is a nice feature. And then the problem is when you turn the wheels is you got to get them in alignment. So there's a couple alignment things you got to watch for. And the turning one, you got to make sure that you're parallel. So this wheel and this wheel are parallel. If they're not parallel, if they're off just a little bit, what will happen is Your lower wheel, every time you wheel, will go one way. You go into the panel, it'll go over to this side, and then you come out of the panel and it'll jump over this way. And you'll hear it making a racket. So now this has an end play adjustment on it with these little screws here. It's off a little bit, it's kind of floating around. These have an end play adjustment. This one's pretty tight. I should adjust it, but that's not going to make a big deal. But it's nice to have them tight if you want to. So you eyeball them to make sure that they're parallel. If they're off a little bit, then you got to loosen the nut and turn one of the yokes here to get it in alignment. And if you see the wheel jumping side to side, that means it's out of alignment. And the other alignment issue is, this is a real low crown anvil, and we bring the wheels down so they touch. It should be touching right in the middle of the anvil. This is offset just a little bit because I never shimmed this out. I have a wider top wheel. It could stand the shim right here, probably like a 60,000 shim or so, and bring this whole lower support over, so I'd center it on here. But because I use wider wheels than most people use, and the reason for that is it really stabilizes the panel. The narrower the wheel, if you take your panel and you go off of horizontal, the edge of the wheel bites in real hard. The wider the wheel, you don't have to worry about that biting so much. So let's get a piece of metal, and we'll throw the metal in there, and I'll just show you a few different things that the English wheel is capable of doing. Yeah, my yokes also feature a set screw on the bottom here, and the same thing on the top yoke, where you can change the angle of the wheel, so you can, that's adjustable. So sometimes you might want to kiss this edge of the wheel, like if you're tipping an edge, you can kiss that up against the top wheel, and that will help tipping. And it's a good way to be able to dial the anvils in. All right, Mark asked me, he said, we should really talk about the different components in the English wheel. Well, we have the frame. This one has a nice 3-leg setup that's really well balanced. And then we have the adjuster here. And this is a really nice, super quality adjuster. We have a big bronze bearing in there, a bushing rather, and it's super tight. And we make the yokes with all this adjustment capacity so you can fine tune them. And we also have the lower piece. You can, it clamps it, and you'll have to drill another hole if you want to put a bigger yoke or a bigger wheels on the bottom. You have a lot of different things you can do. That's the upper yoke, that's the lower yoke, the adjuster, and then the lower holder mechanism. Yeah, and then we have the top wheel and the lower wheel. Now, most top wheels usually are 3 inches wide. Some of them are 2 inch. We have like a 4.5 inch wide wheel on this one, and we have wider wheels on some of our other English wheels. And I found that to be a very useful feature, and that helps you balance the panel out. You don't have to be always on horizontal. You can be off horizontal a little bit, and the wheel will correct you. So it's a nice feature. So what we're going to do now is, we've got 2 pieces of metal. I cut them the same size. This one is steel, this one is aluminum. This is what's called cold rolled steel. I believe it's a 1010 is the designation on it. In Europe they have a different number and stuff. And this is 40 thousandths thick, which would be a little bit more than 1 millimeter. And this is the aluminum. This is 3003 alloy. And 3000 alloy welds nicely. It gives you pretty good strength. And I believe it has a little bit of magnesium in or something. As opposed to 1100 alloy, which is pure aluminum. And this is 060, and this will give you really good dent resistance. Even if you thin it out a little bit from putting a crown in it, it'll still have that really good dent resistance. It's about equivalent to what 040 steel is. And the aluminum, of course, is a little more malleable than the steel, and plus you have the ability to anneal it. So I just wanted to show you the comparative results, and I choose these sizes because 060 aluminum is what you want to do for any collector car sheet metal. You'll find that some of the collector car sheet metal is actually a little thinner. If that's the case and you want to keep it all authentic, then you follow whatever the original sheet metal thickness was. But if you're scratch building your own copy of a collector car, what you want to do is this 060, because that'll give you a much better dent resistance. And you'll find that most collector cars, we're talking cars from the early 1900s all the way up to the 70s, you're going to find a lot of them are 040 thickness. So that's, I call it the Goldilocks. It's still easy to work and it provides good strength, as opposed to 20 gauge, which is easier to work, but it doesn't give you the good dent resistance or strength that the 040 will. And a lot of people choose 18, which is 45. There's a 5 thousandths difference between them, 35, 40, 45. And 18 is more difficult to work, and it actually gives you more dent resistance, but there's no point in actually, I don't see the point in going a little thicker on your steel. On the aluminum, I do see the point of going a little thicker. Some of the cars have 40, and some of them have 50 thousandths, and you might find some even with 60. But let's do a little comparative example here where we compare what happens when you English wheel aluminum versus steel. So we'll put it in here. And there the wheel is just starting to touch right there. So I always have a red ball on all my adjusters so I can find out where I'm at. So it's just starting to touch, and I'll do let's see, maybe we'll do one turn, and that yields still a low pressure zone result, and we have a low crown wheel in here. So if Mark can come closer, you'll see this low crown wheel will leave a little track, and this one's yielding about, I would say, 5/8 of an inch or so right there. That's the actual contact area. So every time you push this through, you're going to get a 5/8 contact area interface between the two wheels, squeezing the metal. So let's just go back and forth here for a few minutes and see what happens. And this is still in the low pressure. Now what we're doing when we tighten this screw up, we're energizing a spring basically. This frame is a spring. So we've got, with that screw at tensioned at to that degree, we've energized a certain amount of this spring. We can go a lot more turns here, but let's just do this really light. It was like one turn of the wheel, and I should count the back and forth. I probably got about 20 in here now, and I'm going to hit the whole panel, going all the way to the end and all the way to the sides. And what's happening here is it's squeezing the metal, and the edges are not touched. So what's happening is the edges act like fences, and they fence in this squeezing that we're engaging in on the panel. And because the top wheel is flat, the panel can't go up this way, and the bottom wheel has a little bit of crown to it. That's why you get this crowning action that happens. So there is maybe 40 back and forths here. And you can see that snapped a little bit. And now what we got, just at 40 back and forths, we've got a really nice surface. You can see that surface. It's a beautiful, flawless surface. And we have, let's put it on a flat bench and we'll get a straight edge on it, and we'll see what kind of crown we have. All right, we've got a super flat table here. And if we push the sides down like this, and we put that straight edge there, that was like 40 passes back and forth. You can see that that center rose about 3/4 of an inch. So that aluminum, pretty reactive, pops a compound in it really nice. Now, where would you use this compound? This is very typical of a panel This is one of my student Ed's Alfa Romeo that we're doing at the class. And say we're making this panel right here. Now, this has a little bit of a compound in it, but it also has the addition of a roll. So if we want to make that fit that surface, there's two elements. One is the compound, which I call area value, and the second is the bending, which is what I call the arrangement value. So first you have to put the area value, how much you create the compound, and then you add the arrangement value. So let's do the comparison with the steel now. We didn't change the adjustment on the wheel. Well, we will have to because we're different. So we'll have to back this off, find the, and you can see what happened here. It picked up a little dirt from the panel. Let's wipe that down a little bit. Remember that the metal is granular and it has little spaces in it. And I washed those panels with lacquer thinner and it comes out and it'll settle on the wheels. So let's put the steel in. This is the 040 cold rolled 19 gauge. We'll find the point where it's slipping. There it is, slipping. Now it's engaging. The red ball is over here, and we're going to turn it one turn. So there we got the same amount of pressure on it. That frame is energized. Now let's do like 40 passes back and forth here. And I'm not counting again, I'm just kind of traversing the panel. Try to put the same amount in. All right, Mark counted it. So there we have the panel. Shows a beautiful surface. It's starting to shine a little bit. This is what happens after usually about 5 minutes of wheeling or so. That polished surface will print onto your panel and it'll turn into a chrome plate condition. So almost the same amount of wheeling, and we push that down and we got about a ½ inch here. So the aluminum actually moved a little bit faster. But still, that's quite a bit of shape in the panel already in a real short amount of time. So now, say we were fitting this over to here, and this isn't the way I fit stuff. This is called marrying a panel. It's commonly done, but I have a flexible shape pattern that I would use for fitting this, because this is a full surface buck that Ed had made. But just as a crude example here, I've added some area, and now I'm going to add some arrangement to the panel. All right, so that was the engagement point right in here. And now typically, let me show you some of the English wheel patterns. And I'm not a really English wheel pattern guy, but you have to know how to do it, and I do use it a little bit. That's if, let me check that again. Okay, so if you wanted to raise the center a lot more than you wanted to raise the edges, what you want to do is work in the center. And you want to get a perfect panel, you want to have really closely overlapping wheel pattern here. So the technique is to remember where you are and to move over a little bit at a time. And if you wanted trying to pump the center up more than the rest of it, you would spend more time in the center. So it's a short back and forth. And I've got some dirt in there. I can feel it. I don't know where that dirt's coming from. All right, so we're going to go one end. So you want to do these shorts and then longs. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's spending more time in the middle. It just makes more sense. An analogy would be if you wanted greater coverage, if you were painting this with a paintbrush, you would spend more time in that center of the panel, and then you would drag the paint out to the edges. So, and being methodical about it is overlapping your contact area every time. I tend to not do that. What I do is I just watch the surface of the panel as I'm working it, and if I see a fault would be an undeveloped area, then I would go after that fault. I'll just drive over there and go after it. Now, this is a situation where I fell out of the panel. You don't want to pop it in like this. You go in at a 45-degree angle and it lets you right in, and it doesn't stress the wheels or the machine or anything else. This spinning and all that stuff is not good stuff. Just go in on the side. You don't need a quick release. And one of the first things is navigating through the panel. If you've never used the English wheel, it'll take about 5 minutes for you to learn how to navigate through the panel. It's very difficult to explain, but it's just this little zigzag motion, and you can go any way you want at will at any time. And it becomes intuitive, and your brain figures it out real fast. It happens at every class I give. People have never English wheeled, and in 10 minutes they're really competent in navigating through the panel. So you can see that's got a really nice crown popping in there. We're popping it up a little bit more. Now, one of the errors that a lot of students make is that they don't realize that you don't want to wheel the edge. You want to come up to the edge, but you don't want to get right on the edge. So what happens is the student in the learning process will think that going on the edge is a good thing. Now let's do that. Let's go on the edge. We'll go on the edge, and what will happen is when we release it, it's sort of like opening the dam and you're letting all your compound right out of there. So that edge will pop up. If Mark can see that, this side is coming down, now this side is going up like that. So if that's the case, what happens after a little while, that edge will have more area than it can deal with, and it goes into a wave formation. And this happens a lot at the classes, that people will dwell on the edge and then they'll release what they've just put into it, and they'll say, I've been wheeling for half an hour and nothing happened. Well, you worked on the edge. And they say, no, I didn't. But then you can see that it's all shiny, and that's a dead giveaway. This one hasn't been wheeled. This one has been wheeled. So if a little bit more on that edge, and it'll go into that wave. Now you can see that it's starting to go wonky on me. It's going like this. So the correction for that is not going over to a kick shrinker and kick shrinking it. And especially the Lancaster copy shrinkers, they're pretty rough on the metal, and they'll leave these marks in there. They will sand out, but it's not what you need to do. What you can do to fix that is, instead of shrinking the edge, you work inboard right here. right here, working that will correct that edge, and it does the exact same thing as if you had shrunk this edge, but without the cleanup problem, without making the marks. So I'm going to take this, I go in, and I'm going to 45 it like this. What does 45 it mean? I'm at a 45-degree angle instead of running parallel with it. And I'm working inboard. Now, why am I doing 45s? If you do them at 90s like this, you tend to fall out of off the wheel. If you're at a 45, you won't. But you just go up to that edge, and we'll build this back up and create that nice balanced compound that we had before we wheeled on the edge. Now, edge getting loose is a very common very common phenomenon on every panel you work on. If you're working in the center of the panel, it just seems that like all the edges always seem to want to be waving, and you correct those wavy panel edges by going at this 45 like this. So you can see now we've got it diving down again, and we don't have the wave anymore. So it only took a couple minutes to fix that. We could stand a little bit more, so we'll go a little bit more. And blend it all in. So let's see where we're at now. Surface looks perfect. We've got a really nice flaw-free surface. This is the aluminum, 060. We had about 3/4 of an inch of rise in it. Now we got, what do we got? Looks like about an inch of rise now. So we got a nice clean compound on there. But that's the first step, is adding the area. And of course we'd be following the dictates of a buck or a flexible shape pattern. In this case here we're just free-forming it, but we're going to try to fit it onto that nose of that Alfa. So now we want to put some arrangement into it. Arrangement is bending. So we've got the area or the stretch or the compound, that's in. Now we put a little arrangement in it. Now what we do with the wheel this way is it's fulcrum and lever. This is the fulcrum, the bottom wheel is the fulcrum, the panel is the lever, and I have this leverage so I can pull down. So just a little bit of force with my hands down causes the reaction of the panel to start to bend. And you got to do it a little at a time, or you'll get little fulcrum marks from the wheel if you go too strong. And those will all come out, but it's best to take your time and just tease this over. We go this side. Now we're setting the arrangement right now. Now we still have a little pressure on the wheel, but we're not concerned about adding area. We're concerned about adding arrangement. All right, now let's put that on the bench now and see what that looks like. So now you can see before, when I put these edges down, these were up over here and I had to push that down, but now I got these coming down. I can get these to come down too if I want to. That's bending. So the process would be fitting in this panel. Now this needs a lot. You can see how it's rocking. That's going to need a lot of arrangement in order for pulling that all around. So let's see if we can put that greater amount of arrangement in. Now you can also bend this, oftentimes I bend this over a pipe with a blanket on it. But there's always 2, 3, 4 ways of doing every task. I'm just showing how to do it with the English wheel right now. I got super low pressure, so I'm not stressing the wheels or anything. I don't have to go in at a 45 because there's not enough pressure there. I'm just pulling that over. Now, a lot of people think you have to make a panel according to the wheel you work with. Well, this is a really low crown panel, and you can see I'm making a pretty good crown in this panel. It's just the way you work the panel. You always want to use the lowest crown wheel that you possibly can. Now, if you're too low and you're making the panel, it's too high for that wheel that you're using. What will happen is you'll get wheel bite. The crown of the panel will be hitting the edges of your anvil, and you'll get these little wheel bite marks underneath here. Then you have to either work the panel out of arrangement or go up with a higher wheel. One more crown up. So now we got quite a bit of arrangement happening in the panel, and you can see there's our crown now. With that amount of arrangement, our crown value is only about 3/8 of an inch. So let's see how that fits over here. And we're just giving an example. Now, before it was rocking like crazy, and now it's only rocking a little bit. So I got to pull these corners down. They need a lot more than here. So now I'll pull the corners down. Now, that's what I want to show you. See what's happening right here? This is, if Mark can get that, that's a really low crown anvil, and now I'm hitting the corners, the edges of the anvil. That's wheel bite. So I got to be very careful pulling these corners down. I'm going to have to go up to a higher anvil. So let's change out that anvil so I don't get that wheel bite. All right, so we put a little bit higher crown anvil, and it looks like I got some dirt on it here. Hold on a minute. All right, so the wheel's all cleaned up now, and let's see if we can pull that over without making any marking. So let's see what that did. This is not the way I do it, but it just shows you the process. So you can see before that was way away, and now we're getting closer and closer here. Let's do this one a little bit. We got about an inch. You can always quantify this stuff, about an inch and an inch on that one. We'll pull those over. And this is using the English wheel as a bending tool. Not necessarily making compounds, just bending. It's strictly a fulcrum and leverage tool. All right, so you can see that is curving over quite a bit. Now we would have a spot registered here with magic marker or something if we were getting this right on the money. Now you see this corner needs to come down a little bit too, so we'll pull that corner down. And this corner, if Mark can come around, this corner has too much bend. See how that's hitting over here? So we got to take some of the bend out of that one and add some to this. So how do you take it out? So to take it out, all you got to do is now, instead of push down, you pull up. So we're taking that out. And then we're going to add to this one. We're going to pull this down here. And just do a little bit at a time, and you got a feedback off of your panel that you're copying. So we'll go up here. Now see, Mark can see that. Now see, that fits right in there nicely. This has got too much bend here, and it actually needs more bend right here. So I got to take some of that out and add some more there. And then on this side, they both need a little bit more. But see this? I still have some rock, and it's rocking right in here. So that tells me I have to put more area right in the center of that panel. So using this wheel again, well, let's pump this up just a little bit. We'll get the same point. There's the slip point. We'll bring this around one turn, and we'll add some area in the middle there. And this is why, if you're doing the English wheel pattern system, you would go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, because it adds more in the center, and that's generally the case. It needs it in the center of the wheel, or the center of the panel. Now the neat thing is we're sneaking up on the fit here. You only do a little at a time and check, always work and then check it. But if you do screw up, you have the ability to correct really easy. How do you do that? Well, if you make this too strong here, then you have to wheel the edges. We showed you before how I wheeled that edge and it took the crown right out. So we have the ability to add and subtract. So slowly but sure, that thing is fitting better. Now you can see I'm rocking, and it's right in here. And if you see right there, it's scratching the panel right there where it's interfacing. So that's where I'm going to add the extra area. So you just have to wheel for a couple minutes, sometimes only a minute. Depends on how close you are to the finish line. You're always going to that finish line. You never want to give ground. You want to get it to fit better and better and better. All right, so now it's rocking right in here, so add some right in there. And we can measure how much that's rocking, and the next time we go over there, we'll find that it rocks a little bit less. And this is a way to make patch panels if you want to. It's called marrying a panel. It's one thickness removed, but it's pretty close. So right now we have about 3/8 of an inch where it still needs to come down here. And we got some arrangement issues here. I got a little bit too much of this, so I'm going to take some of that out. That might help. So we'll loosen that up. So it's bending too much right there, so I'm going to pull that out a little bit. Just a little bit, and then we'll check it again. Oh, look at that. That's a lot better. All right, so we're still rocking. There I gotta find out the spot where it's interfacing there. Okay, that's digging in there. I gotta take some of that out too. I got a little bit too much there. Now, in the process of making this panel, if we're kind of going at it at a little faster clip than we normally would do, we'll have some surface issues. And this has a little bit of wheeling marks on here. But after we get this to fit really close, then we'll deal with those wheeling marks. So let's see where that is hitting. Do a little scratching on here, and there's where it's hitting right there. So I got to add more area right in there. The panel takes on a nice tone, so gets a little stiffer. It looks like I took out a little bit too much of the curve there, and I add some here, take some out of here, take some out of here. Let's adjust that arrangement a little bit. This arrangement was too late. I wanted to get it over here. So it's getting closer and closer every single time here. And what are we down to now? Look, it's about 3/16 of an inch. I got a little arrangement that's got to happen there. And sometimes you can just do the arrangement with your thumbs here. No, it looks like I'm going to have to do some more. So, still right in here. Now see, that's less and less bouncing there. So let's put some little index marks. We'll go back to the same spot every time. We got it here and here. And now let's do an analysis of where we're at. So we still got too strong a bend in here. We'll take that bend out a little bit. Still too much. Take a little more out. So that's following that contour pretty good now. Still a little bit right there, but not bad. All right, now let's look at this side. And this side is a little bit too much right here. Similar problem. We just take that out with our thumbs. And then we add a little bit right here. Now that's fitting better. So, and then what do we got on the bottom? The bottom's fitting good. And let's see. If we got any, you got to hold it really tight and rub it a little bit. See if it's hard to see it now because you got so many other rub marks. There's a little bit of rubbing over here, so it might need a little more right in there. So we have the area value really close now, and we have the arrangement value really close. But the next issue is surface quality. Our surface quality is not the best because we've been kind of going fast at it. And I don't know if Mark can get those little waves. You can see them, there's slight little waves in here. And the issue here is to try to even that all out. The tool I use is I call the horizon view. I hold it up like this, and you look for anomalies in that surface flow. And generally I call them weaks and strongs. So the weaks have to come up, the strongs you stay away from. So I'll look at that and find my weaks. I can see them. Back this off a little bit, and I'll just go in those little weak areas and pump those up a little bit. And you got to let the light dance across it. The shadow actually helps you out a little less light sometimes. And you just find them, and all you got to do is go a couple passes through there and it'll correct it. Even it all out nicely. Now, if you're doing the English pattern wheeling, generally you wouldn't have to do this because you're going to be so methodical you wouldn't allow this unbalance to happen. Essentially, the panel is a little bit unbalanced and the surface quality is not perfect. We've got a really good fit, but our surface quality is off a little bit. So, but we can chase after that and fix all those spots and get that really looking good. Now we probably could go back to that other wheel, although it's got a little bit more crown than I like over here. It might bite, but we'll use this one, I guess. Now what we'll do is we'll do a methodical cross right across the panel. And if there's any surface quality issues, you'll be able to feel them. They're little vibrations. And this won't add much area because I got a low pressure here. And I'm going to be hitting pretty much the whole panel, so it blends it all together nicely. It might change the arrangement value a little bit. Sometimes wheeling will open the panel up a little bit, so we might have to close it a little bit when we go back to fitting it. Okay. All right, so you can see now we've got some pretty good panel fit. There could be a little bit more, and we also have some pretty good surface quality. And it'd probably take another half hour to perfect this panel. Mark is already over his closing time here, so we've got to hurry up. But I hope that really helped out understanding what needs to happen. As you saw, that was a flat panel, and now it's conforming to the surface pretty nice. Plus we have a pretty nice surface quality on it, even though it's not finished. A little bit more work. All right, to get this surface quality right up to snuff, which is a mirror finish panel, we've got the area value pretty close. It'll dial in a little bit better. The surface quality will dial in a little bit better. The arrangement value will dial in a little better. Those are the three values you want in every panel. You want the area value first, the arrangement value second, and then your surface quality 3, the last. And then you'll end up with a really nice panel. So these are some of the basics of English wheeling. Every panel you do is going to be the same. And yeah, every panel is fun. Every panel is unique. And there's nothing better than aluminum. You got to try aluminum. A lot of people are reluctant to switch from MIG to TIG. There's a reluctance to switch from steel to aluminum. Try some aluminum. You'll love it. I really just want to spend the rest of my life building aluminum-bodied cars. It's a lot of fun. So I hope you enjoyed the video. It's Ray from Pro Shaper Workshop in Charlton, Massachusetts. And please remember to subscribe, give us the likes, and hit that little notification bell. Tell all your friends. Remember that metal is clay.